live, sir.
Outstanding, thank you. Again, welcome everyone. Good morning to those on the West Coast and good afternoon to those here. And welcome to the NRC for our meeting with Holtec International. My name is Richard Turtill, and I've been in touch with many of you in the last probably 4 days. Thank you for your interest in this meeting topic. I have a few procedural comments and information to share before we get started with the meeting. For those in the room, if you are not an NRC employee, as you know, you must be escorted at all times once you leave this room. Therefore, if you need to leave the room for any reason, please ensure that an NRC employee is with you. At the end of the meeting, we will escort you back to the lobby to turn your visitor badge in and to exit the building. In the event of an emergency during the meeting, please follow the NRC staff outside the building, this front door, so we can ensure that our visitors have all made it out of the building safely. This meeting is open to the public and was first noticed on March 26, 2019. The meeting was extended by half an hour to accommodate more time, a total of 45 minutes for public comments and questions, and that meeting announcement is at, many of you are familiar with our ADAMS document control system. It's called ADAMS, and that's, I will give ML numbers. Folks may refer to ML numbers from time to time. That announcement was at ADAMS accession number ML 19092 A251. This is a Category 1 public meeting. During the meeting, the public is invited to observe the meeting between the NRC and Holtec International. Prior to adjournment of the meeting, the public will have an opportunity to discuss regulatory issues with the NRC once the business portion of the meeting has concluded. Several members of the public are in the room, and many are on the phone today. Again, we reserve 45 minutes at the end of this meeting for public comment. Information considered proprietary will not be discussed during this public meeting. The Holtec presentation has been provided to you and will be available in the NRC's ADAMS system shortly. Now, as background, in March 16, 2019, a letter from Holtec was received by the NRC in which Holtec requested a public meeting with the NRC to enable them to present their regulations informed position on the scratch matter for NRC's consideration. Holtec indicated its desire to establish a path forward to resume loading at the Song site, that's the San Onofre site, and requested the meeting occur in the afternoon so that concerned citizens on the West Coast could participate. That letter that came in is, again, ADAMS number ML 19077 A021. With that background as presented, I'm going to turn the meeting over to Michael Layton. He's the Director, Division of Spent Fuel Management. I'll note that after Mike makes opening remarks, he will make introductions for meeting participants in the room here. However, there are as many as possibly 60, maybe 70 participants on the phone. So I will ask that if you wish to be included in the list as attending this meeting, please send me, again, my name is Richard Turtill, and most of you have heard from me, an email indicating in the subject line something simple such as Holtec meeting, include me as attendee. And with that, I'm going to turn this over to Mike Layton.
Yeah, thank you, Rich. As Rich said, I'm Michael Layton. I'm the Director for the Division of Spent Fuel Management here at NRC. And we scheduled this meeting at Holtec's request to receive information from Holtec on its high storm UMAX certificate of compliance. Rich alluded to the agenda. We have a period of time set aside for Holtec to present technical issues to the NRC staff, and also some time for NRC staff to ask some clarifying questions. And then also an opportunity for the public to comment to the NRC after the presentation. So what I'd like to do right now is go around the table with introductions to my left, so to speak, rather loudly so that it can be picked up by the microphone.
And I'm Linda Allen, the Deputy Division Director for the Division of Nuclear Material Safety in Region 4.
John Kurgan, Chief of Spent Fuel Licensing Branch here at NRC headquarters. Richard Turtill supporting John in his branch.
Kris Singh, I'm the Chief of the Inspection and Operations Branch here at MSS, and my apologies for being late.
Hello, I'm Chuck Bullard. I'm the Director of Engineering Mechanics at Holtec International.
Kim Manzione, I'm the Licensing Manager for Holtec International.
I'm Stefan Anton. I'm the VP of Engineering and Licensing at Holtec International.
Pierre O'Neill, Chief Nuclear Officer
Associates.
Tom Palmisano, Southern California Edison.
Don Shaw, member of the public.
Bill Horowitz, member of the public.
Christopher Regan, Deputy Director, Division of Spent Fuel Management here at headquarters.
I want to listen to
Maraj
this.
Ravini, Chief of Renewals and Materials Branch, NRC. And for the folks in the back row, if you don't mind speaking up because you're a little bit away from the microphones.
Christy Jacobs in NMSS.
Ted McCartan, NMSS.
Dave McIntyre, NRC Public Affairs. Mike McCall with Wax. Vivian Reddy, NMSS. Carol Dunn, NMSS.
Corey Bjorkman, Senior Technical Advisor, Construction Mechanics, NMSS.
Patty Gailey, NRC, Office of the General Counsel.
Brian Harrison, Senior Level Advisor for Risk Assessment in NMSS. Donald Jones, NRC, with Allen. Angel Moreno, Congressional Affairs, NRC.
Amani Quintano, NMSS.
Well, thank you. That's all the folks that are in the conference room here. What I would like to do is talk a little bit about the purpose of the meeting in a little bit more detail, and also some of the ground rules. This meeting, again, as I mentioned, was requested by Holtec. We have no actions at the NRC before us on Holtec certificate, the high storm UMAX at this time. And hence, we will not be making any commitments or regulatory decisions associated with that certificate. This is an informational exchange, and NRC is really in a listening mode. We may ask some questions, but it'll be more for clarification to help us expand our understanding. And although this certificate is associated with spent fuel movements at San Onofre Nuclear Generating Station, any site-specific discussions are out of scope in this meeting. I recognize that that was a topic that was included in the request for this meeting, but because many of the items that are associated with the decision to restart the reloading activity at SOMS is an inspection-related item that's before the NRC now and is with NRC's Region 4 office. Any of those specific questions are out of scope of this meeting, so we will not address those in this meeting. Are there any questions from anyone before we proceed and have the meeting turned over to Holtec? Hearing none. Stefan?
Okay. Good afternoon. Thank you very much for the meeting. First, I want to extend Dr. Singh's apology that he couldn't attend the meeting for personal reasons. He was not able to attend, so we miss him here, and I'm not quite sure that we can replace him, but we'll try our best. Again, thank you very much for giving us the opportunity here to speak. Yes, we asked for the meeting to give some additional information. The issue of stretchers for the MPC has come up in the past, and we felt that this is not just a specific issue, that there are generic implications, generic issues with respect to these any stretchers on the MPCs. And we thought it is more than appropriate and necessary that we take any actions on that and present our view and what activities we've already taken in that respect. They include there are two parts to it essentially. There are some technical discussions that we will present to you, and there will also be some licensing consideration from our perspective that we will be discussing here in the meeting. We understand that there will be no regulatory decisions. That is perfectly clear and understandable to us. We have been in many of these meetings. We do hope that through any questions and discussions, that in the end we get a little bit more of a clarification. But the discussions will in the end see where this all takes us. And just to have the discussion by itself and our presentation will be very valuable to us and hopeful.
I just have one quick question. Okay, if I may. I'm just looking at the slides now as we received those last evening. Many of these are marked as Holtec's copyrighted material.
They're not proprietary.
Okay, so are you all right with those being put into Adams?
Yes.
Okay, thank you.
believe everybody on the phone, as well as those in the room, have a copy of that presentation. What we want to talk about, as we indicate on the title slide, is the incidence and consequences of surface scratches on the MPC shell as it relates to our high storm UMAX canister system. So, moving to slide 2, in terms of the presentation agenda, there are two main sort of areas that we will cover today. The first is consideration of the scratches, their occurrence, as well as their treatment with respect to the ASME code and regulations and our license or certificate. And then we'll also take some time in the presentation to talk about the specific information that is in our UMAX FSAR and discuss the basis for any changes to that material. Turning to slide 3. So really for today, we, Holtec, have two principal objectives for the meeting. The first is that we want to present to the staff and to the public our regulation-informed and ASME code-based position on MPC surface scratches for the staff's further consideration. And also we want to provide and explain our case for why we believe that the specific statements in Chapter 9 of the UMAX FSAR, specifically Section 9.5, regarding the risk of scratches during canister loading, why that information is not safety significant and it does not affect the functional performance of the UMAX system under the COC that's been granted by the NRC. So moving to slide 4, just briefly talk first about the origin and prevalence of scratches. Scratches on plates and shells, specifically the MPC shell, are not unusual. In fact, they are a common occurrence, especially when you consider the manufacturing aspects of the MPC, the handling of the raw material and the plates, the various manufacturing activities that the plates are subjected to, bending, forming, shearing, etc. It is fairly common and even expected that there will be surface scratches on these plates and shells throughout that process. And similarly, it wouldn't be uncommon, even in the field during handling, that there may be some incidental surface scratches on the MPC as well. As a manufacturer, we have procedures in place so that we can limit the admissible depth and population or density of the scratches. And we control that, or we screen that using our manufacturing procedure HSP 320, which places specific limits in the manufacturing space on the depth and size and density of the scratches. Moving to slide number 5. So what are the mechanisms by which these scratches occur? There's two basic, when we talk about the MPC and the MPC shell, there's two basic mechanisms that we've observed and we've noted that are the physical mechanisms for causing these scratches. The first is simple abrasive wear, when you have two materials that are rubbing against each other. Usually there may be a harder material involved that impinges or rubs against the other material, in this case the MPC shell, under some contact load. That is one form of wear and one cause of the surface scratches. The other effect or phenomenon that is in play here is adhesive wear. And this can occur when the materials are compatible or have similar metallurgy, such as austenitic stainless steel, where you have a bond bonding of the material and a transference of the material across the two interfacing surfaces. So it can deposit material on one surface and remove material from the other surface. So there's a combination of effects here, both abrasive wear and adhesive wear, that we observe both in the manufacturing space and in the field as well. What we do know, and we can say in general, is that the depth and width of these scratch marks are proportional or related to the contact force, and they are also dependent on, as we say on the slide, the state of armor on the stainless steel. What I mean by that, the state of armor, is that differing plates may have differing chromium oxide layers that act as a barrier, and the indentation hardness, or the Burnell hardness, which is a common measure, that may vary from one plate to the other. So that can also influence the depth and width of the scratches. But most certainly the magnitude of the contact force is a key driver that determines the scratch depth and its size. In terms of prediction, when you take into consideration the differing effects, as I mentioned, both abrasive wear and adhesive wear, it becomes a difficult process or a difficult exercise to predict these scratches numerically using analytical tools to determine a scratch depth. There are techniques for estimating the abrasive wear. The effects of adhesive wear become even more difficult when you attempt to predict them by numerical techniques. I'll move to slide 6 now. So we want, in general, to try and minimize the extent of scratching. But we don't minimize scratching at the expense of all other design and performance considerations. There are other factors that we have to take in consideration in conjunction with the scratches as we develop the design. And what I mean by other considerations are things such as radiation dose, seismic design, seismic resistance. And when we talk about the UMAX storage system, two specific examples of that are the UMAX module has a shield ring near the top of the cavity. And the shield ring, it has a specific purpose to limit the radiation dose to the crew during field operations and the MPC download event. So for that shield ring to be most effective, the clearance gap between the canister OD and the shield ring is kept to a minimum to the extent practical. And in this case, the diametral clearance is approximately a half inch between the ID of the shield ring and the OD of the canister. And that enables us to effectively reduce the dose in the field during download operations. Likewise, when the MPC is seated inside the UMAX, there are seismic restraints that brace the canister inside the module and mitigate the loads on the canister during a postulated earthquake scenario. So that also calls for fairly close clearance gaps between the seismic restraints and the canister. So the end result, based on those design decisions, is that we have a UMAX system that has a very high seismic tolerance capability, and we've also limited the dose to the crew during the field operations. So as designers, we've made a risk-based decision. We weigh the risks of surface scratches against other performance objectives and performance needs. And in this case, our conclusion is that the scratches that we're speaking of are mainly cosmetic in nature or of insignificant consequence, and they're tolerated in the interest of the other performance benefits that I just mentioned. from an ASME code standpoint, it's fairly clear-cut when you look at the code definitions that these surface scratches are examples of local structural discontinuities. So I want to take a moment here to explain what I mean by local structural discontinuities and give some examples. A local structural discontinuity by code definition is it is a stress concentration that affects the stress and strain distribution for a fractional part of the wall thickness. And it also does not affect shell type deformations. It typically doesn't cause any visible distortion of the shell. Examples of a local structural discontinuity may be a small radius, small fillet radius, a small penetration or opening, and in the slide 7, we show a couple other examples that are specific to the MPC itself. One example would be the small lifting holes that are in the lid, the MPC lid, which are used to handle the lid as well as the MPC. And even if you think about the lid to shell weld, which is part of the containment boundary, that closure weld, even the surface of that weld, which hopefully you can see in the close-up photo there, it's quite uneven, and there's numerous ridges and undulations in that surface. So even those irregularities in the weld would be examples of local structural discontinuities, as well as any surface scratches on the MPC. So the point that we want to make here is that local structural discontinuities are quite prevalent on the MPC canister in many different forms, and scratches on the surface is just one obvious example of a local structural discontinuity. And the slide also points out an example of a gross structural discontinuity, which is at the bottom of the MPC. This is sort of the classic example where you have the shell to base plate joint, where you have a 90-degree corner. And what differentiates a gross structural discontinuity from a local structural discontinuity is that gross structural discontinuities affect the stress through the thickness, and they're typically throughout or uniform throughout the shell diameter. So that's why something like the shell to base plate joint is a classic example of a gross structural discontinuity. And it's important that we point that out here because in ASME code space, dependent on whether a feature is a local structural discontinuity or a gross structural discontinuity, it affects or influences the stress category and how those stresses are evaluated or categorized and subsequently evaluated within the ASME code. So again, just to conclude on this slide, MPC or surface scratches on the MPC shell would be clear examples of local structural discontinuities within the context of ASME Code Section 3. Moving to slide 8. I'd like to take a moment here to just talk about the UMAX system, and which is a vertical canister system, which by design helps to minimize or mitigate the scratches that may occur in the field during handling and loading operations. The one valuable benefit of the vertical canister system is that the contact loads that develop during downloading and field operations are significantly reduced as compared to a horizontal canister system, because since the canister is hanging vertical, the lateral contact forces, by virtue of the confined space and the limited freedom of movement of the canister, those local lateral contact forces are limited to a very small percentage of the total canister weight. When you look at the UMAX system and you consider the inside diameter of the high track as well as the UMAX storage module, the maximum feasible rotation of the MPC is very small, on the order of 1 degree. So with such small rotation angles, it's really becomes physically impossible to have a very large lateral contact force between the MPC and the internal features of the UMAX system. And that's why we conclude on the slide that the maximum contact force, even under the worst hypothetical configuration of the MPC, is still only on the order of about 2.5% of the canister weight. Whereas in a horizontal system, that lateral contact load on the shell could be much more significant, as much as the full weight of the canister system. So this limits the potential size and depth of the scratches, and our own investigation, both numerical and through tests, show that those scratches are shallow with respect to the thickness of the shell. And in fact, our estimates of the abrasive wear specific to the MPC inside the UMAX, by our calculations, the depth of the scratch due to abrasive wear is on the order of 1.2 mils, or 0.0012 inches per 1,000 pounds of force. So even if the maximum contact force is as much as 2,500 pounds, you multiply that by 2.5, we're still talking about scratches due to abrasive wear that are on the order of 2 to 3 mils in depth. And the tests, we've conducted some tests in our manufacturing shop to simulate the contact behavior, and we've found that in terms of the abrasive wear, which is more a measure of the average depth of the scratch over the width, is in line with the numerical estimates. But as I was mentioning earlier, we also see in the actual test results that there's evidence of an adhesive wear as well, where there's some surface galling, which can create peaks and valleys even within a specific wear mark or scratch mark. So we do see, when we look at the combination of abrasive and adhesive wear, that the depth, the maximum depth of those valleys, considering both effects, can be larger than the 2 to 3 mils that I just stated due to abrasive wear. Slide number 9. Next. So continuing what I was just saying a moment ago, when we look at the shop test results as well as our numerical predictions and finite element analyses, we see consistency between them, that the maximum average scratch depth, which is more of a measure of abrasive wear, is bounded by 2.4 mils, 0.0024 inches. And to put that into context, the minimum required wall thickness to meet the design internal pressure for our canister, which is 100 psig, the minimum required thickness to resist just that internal pressure load is 0.216 inches. Now that number takes into consideration the minimum strength properties of the material as well as the applicable metal temperature. But for a canister of our size and dimension with 100 psig internal pressure, the minimum required thickness to meet NB 3324 is 0.216 inches. Keep in mind that the nominal wall thickness for our canisters is a minimum of a half inch, and there is an option as well that the thickness can be 5 imperfections such as scratches and other considerations as well. When we look at some of the field measurements, when we've examined loaded canisters, we do see that in general the scratch marks are small in size to the eye. They're not significant at all, almost invisible in some cases. The worst case scratch that was measured in the loaded canisters had a maximum depth of 26 mils at a specific location where we observed a combination of abrasive and adhesive wear and some presence of galling. But it still remains that even the 26 mil maximum depth is a small fraction of what is the minimum required wall thickness from an internal pressure standpoint. So we have a lot of inherent margin in the design to accommodate any incidental surface scratches. Slide number 10. So I want to come back now to the ASME code and the classification of stresses as it relates to surface scratches. To start with, we need to recognize that the MPCs are designed to the highest design standard in ASME Code Section 3. They are designed as subsection NB Class 1 vessels. So this is the same code that would apply to reactor vessel and pressurizers in nuclear reactors. So it's the highest design standard and manufacturing standards for the MPC canister. And when you go further into subsection NB and look at the stress requirements, there are three basic stress categories that have to be considered. The first being primary stress. I've cited the applicable code paragraph there. Primary stresses are the most important and the controlling stress type for the vessel. Primary stresses are limited under all service load conditions, normal conditions, as well as accident conditions. And the primary stress is the basic stress component that satisfies basic force and moment equilibrium. The next tier of stress category is secondary stress. These are somewhat, less significant, if you will, as compared to primary stresses, and these tend to be associated with gross structural discontinuities, which I described or mentioned earlier. So these would be, an example of secondary stresses would be the local stresses in the vicinity of the shell to base plate joint. That gross structural discontinuity would produce secondary stresses in that area. The third stress category is peak stresses. And in terms of the MPC, in this application, peak stresses are not significant to the design or the performance of the MPC, and I'll explain that further. But it's also important to know that peak stresses are also attributed to local structural discontinuities. And we go to the next slide, slide 11. The reason that peak stresses are not of significance as it relates to the MPC is that by code definition, peak stresses are only objectionable from a standpoint of fatigue or brittle fracture. So in the context of the MPC is a passive system. There's no moving parts, there's no active active cooling system. When the MPC is in long-term storage, it's in a static resting state. There are very, very minimal pressure and temperature fluctuations. So there's no credible risk of fatigue for the MPC canister. And in fact, we make that conclusion in the UMAX FSAR. I pointed out Table 3.110. The last sentence in that paragraph I excerpted, it says, because fatigue is not a credible source of failure in a passive system with gradual temperature changes, the cumulative damage factor from fatigue is not computed for the UMAX components. So fatigue is a non-credible failure mechanism for the MPC canister. So fatigue is not a concern when we think of or consider peak stresses for the canister. I also mentioned brittle fracture. That also is ruled out because the MPC in our case is manufactured from austenitic stainless steel, which is a ductile material, and therefore it is immune to brittle fracture failure, which is also stated in the UMAX FSAR with respect to the MPC. So having ruled out fatigue and brittle fracture, peak stresses are no longer of any concern with respect to the MPC and its structural design. And that's why we say here on the slide, in conclusion, local discontinuities produce peak stress, which is immaterial to the safety margin in an MPC. And that's an important technical point, which will then, as we go forward, influence the licensing aspects. But again, I guess just to summarize that technical point, the surface scratches on the MPC are, by code definition, example of local structural discontinuities, which means that they are local stress concentrations which are only capable of producing peak stresses. And peak stresses are only a concern from an ASME code design standpoint from a fatigue and brittle fracture. And neither of those failure mechanisms are credible with respect to the MPC canister and its design. I'll move to slide 12. And this just reiterates what I was just saying, that the local discontinuities are associated with peak stresses, and although peak stresses are common and present in the MPC, there's no risk. They pose no risk to the safety or structural design of the MPC for the reasons I just mentioned. And that is why, of course, in Chapter 2 of our FSAR, under Principal Design Criteria, we do not place any limit on peak stresses with respect to the MPC canister. As I mentioned earlier in Table 3.110 of the FSAR, the fatigue is ruled out as a credible failure mechanism, as is brittle fracture. So there's no need to place any limit on peak stresses with respect to the MPC. And furthermore, if you look at the safety evaluation report for the UMAX system, for those same reasons, there's no mention of peak stresses in the safety evaluation report because they're not. They don't pose any risk to the MPC, and therefore they don't have any bearing on the safety determination with respect to the structural design of the MPC. And likewise, the COC for the UMAX system does not make any specific mention of scratches or local discontinuities or peak stresses present in the MPC. So we think that's important because it doesn't, if those aspects aren't discussed in the FCR or the COC, it implies that they are not safety determination of the MPC. I'll move next to slide 13. And so now I'll get into the licensing aspects a little bit more, moving away from the technical and more into the FSAR and the licensing aspects. And so first I want to kind of classify the contents of an FSAR, and we think of it as in three different categories. The first being safety critical information. And this is material, as you'd expect, that's in the COC, and therefore it is locked in place. You cannot change safety critical information in the COC without a license amendment. The next tier would be safety significant information. And this would be information that's not explicitly in the COC, but it has a safety significance, and therefore it is subject to the 7248 process. And depending on the outcome of that process, you may be able to implement a change via that process, or under certain circumstances it may force you into amendment space. The third category would be non-safety significant information. And we define this as supplemental information that is not relied on to fulfill a safety function and is not included in the NRC SCR. So we wanted to make that distinction to then discuss the considerations of the aspects of the MPC scratches. So moving next to slide 14, regulatory perspective on scratches on the canisters. So the first point that we'd like to make is that the scratches are not mentioned or relied on in the NRC's SCR for UMAX, as I said a moment ago. And in fact, as we did our own investigation, we found that there was no mention of scratches in any of the previous SCRs for any of the Holtec storage systems, which is not surprising to us for the reasons that I stated earlier. The scratches are associated with peak stresses, and because we're not concerned here with fatigue or brittle fracture, those surface scratches and the associated peak stresses are not safety significant, or they don't have any bearing on the safety determination of the MPC. And even when we look beyond our own storage systems and the SCRs associated with them, we were not able to find any evidence where the scratches, surface scratches on the canisters were treated any differently going back several decades. Moving to slide 15. So, what we conclude both from a technical and licensing aspect is that the presence of surface scratches on the MPC are not relevant to the safety determination. And any discussion of the scratches in the FSAR represents what we would consider non-safety significant information, along with other examples of non-safety items in the MPC. And then, as a result, once we come to the conclusion that surface scratches are non-safety significant, then it means that any clarifying of the FSAR discussion cannot apply a change of any safety consequence. And the statement in the FSAR regarding no risk of scratching during insertion in our judgment, can be deleted or amended without affecting
having to request a license amendment. And so we went through this, and our conclusion was that as this is possible without any problems, and so we made that change in our EFSA. As always, of course, this will be available, or that is available for inspection to NRC. It's not submitted for review and approval, but it's always available for inspection. So that I covered just slide number 16. I don't want to read out the text there. I think everybody can look at this and see this. Let me go then to the next two slides. I have some further comments on the licensing connections there. The next on slide number 17, that is still a discussion or some points that are presented there that fits a little bit with the safety configuration or with the safety consideration of this. Because if you look at the big picture, if you look at the EFSA at the section where actually the statement about no scratches is, it becomes clear that this is not in there to specify a requirement. The EFSA section 9.5 is only meant to summarize with some high-level examples why the safety NLR is achieved. It's basically just a commentary at the end of the operational steps 9.1 and 9.4 that really look at all the operational steps. And if you look at all the aspects of 9.5, it's just a summary, and it's specified clearly as a conclusion. And so it made only conclusion based, and it was not intended to any new or additional safety or operational requirements. And interestingly enough, the section is not even present in our other EFSAs. We've added that here, probably for consistency with other chapters, but it was previously not there. And through that addition, apparently this confusing or presumably conflicting arguments made it into the EFSA. And as I said, we have addressed that under 7248 to provide the clarification. Then let me go to the next slide. That is slide 18, and I'll probably have to give a little bit more of an explanation there what our discussion there refers to. As we said before, if something is listed in the COC, it basically cannot be changed, and that is actually one of the criteria when you do your 7248. The first criteria, is it something that is listed in the COC, then you can actually not change it yourself because the COC is not our document. So far, so good, and I think that is generally understood. And the statement about the scratches that we changed is in section 9.4. It's in the EFSA. However, it was brought to our attention that there seems to be, or appears to be, the impression that there is a link between the section 9.4, the statement about the no scratches, and the COC. And I wanted to comment a little bit on this. Apparently, there is a link has been seen between the table in the certificate in the text specs, then some section of chapter 2, and that then in the end points to chapter 9, and the concern was presented to us that this could mean that really the statement about no scratches has essentially become a part of the COC. This is something rather odd and confusing from our perspective, and I just wanted to comment on this. We are very well aware that there are sometimes sections in the EFSA that are included by reference into the certificate. We have these examples in some of our EFSAs for previously, and because for one reason or the other you have a large section of the EFSA that is considered so important that it cannot be changed, and there is a rather than including pages and pages of the EFSA into the certificate, there is basically it's included by reference. In that case, in the EFSA, there will be a clear indication of this. There will be given some examples here. Everything is put there in bold text. There is an introduction saying the next couple of pages cannot be changed in any way, shape, or form other than through a license amendment. I've put a couple of examples in here where we see that. We see no such thing here, and this is a kind of a regulatory precedent. We've seen that in the past, and I think that's always been followed. The idea that something that is not identified in the EFSA could be implicitly included in the certificate, and therefore that any change to that is prevented under 7248 seems rather odd. I think that would be, from my perspective, almost a change in regulatory practice, and I would be rather confusing. Now, I'm not saying that this is considered. I'm only saying this was brought to our attention, and therefore I wanted to comment on that. That I would think that is a strange connection that is if that was made there, because just I want to basically make the distinction between something explicitly included by reference and something just simply reference. I mean, the certificate, of course, references the EFSA in a few places, but that does not mean that these places cannot be changed anymore. It's just that it was important enough to mention that they are there in the EFSA and present some important part of it. So I just wanted to make that statement. Maybe it's not necessary because it's not really a concern, but if it's a concern, I would hope that this may be taken into consideration in that respect. And that brings us essentially to the end of our presentation. We just have a summary. Chuck, maybe I don't know what it is. We'll cover that.
Sure, yeah, I can cover the closing remarks. So I think this slide kind of just does a good job of summarizing what we've said throughout the presentation, and there's a certain logic to the bullets in terms of their sequence or order here. The first thing that we've presented today is that localized scratches are an inevitable factor in regards to the MPC, whether it's a result of manufacturing, operations, or even transport at some point in time. From the ASME code standpoint, the localized scratches are not of any concern from a stress compliance standpoint under the rules and definitions of ASME Section 3. And therefore we don't violate, the scratches don't amount to a violation of any design or licensing requirement in the FSAR. And so that leads us to conclude that the localized scratches are not a safety concern, nor do they affect the NPC's functionality. And then from there, once we reach that conclusion, we can then make the determination that the statement in FSAR Section 9.5 represents non-safety significant information, because it cannot affect the safety margin or safety determination of the MPC. And because we're dealing with non-safety significant information in Section 9.5, it then enables us to use the 10 CFR 7248 process to clarify the language with regard to wear and scratch marks on the external surface of the NPC. And as Stefan said, we've by this point in time have gone through that 7248 process and made specific changes to the wording in Section 9.5. So that concludes the presentation, and really we wanted to explain to you our reasoning and the thought process that brought us to that point, so that you could consider it further.
time and coming in and walking us through both the technical aspects of what you wanted us to understand, and also some of the regulatory thoughts as you went forward with your 7248. And I'll simply make a comment that, and this is more for folks who don't know Part 72 regulations like the back of their hand. The 7248 process that Stefan talked about is a part of the regulation that allows licensees to make changes and tests in accordance with some very specific criteria on screening that are laid out. And if all of those criteria are passed, then the choice is up to the design authority, which is Holtec, to potentially make a change to certain documents on their own without having to come in with a license amendment. So this is the first time that we've heard that you've already gone through the 7248 process for this issue. And like you mentioned, Stefan, there's no requirement for you to submit that for NRC review and approval. It is an item that is open for inspection. So at some point, as we go through our routine announced inspections, that'll be something that we will likely look at, evaluate, as we look at that 7248 evaluation, in addition to others that you've done in the past period since the last inspection that you've done. So with that, I will kind of open the floor to the NRC staff. If there are any clarifying questions or comments.
I have one. This is Marlon Davis. And this is based on slide 8 of the presentation. And essentially, doing the MPC transfer operations, are there lateral loads being applied to the MPC shell as it's going down via the shield ring and or the seismic restraints?
It can occur.
Okay. So you can experience lateral loads on the MPC.
It can occur depending on circumstances. Yes. By procedure, we make every effort to align the MPC so that it's perfectly centered and we would have no contact with either the shield ring or the seismic restraints, but it can't be entirely ruled out.
And based on those, it being less than 25%, you didn't consider it as a part of the evaluation or design aspect. These lateral loads. 2.5%.
Yeah.
So based on the 2.5%, you didn't consider it as a part of this design.
Well, we didn't, but partly because we came to the conclusion, or we knew that surface scratches on the MPC, as you go down that path, would not have any safety consequence on the MPC because of fatigue and brittle fracture consideration.
Okay. And then one more question. What is the shield ring? What's the material on the shield ring? Is it carbon steel?
The shield ring is carbon steel with a painted coating.
And did they consider doing the design, a part of it, cross-contamination from the stainless steel to the carbon steel?
We did, which is why it does have a painted coating on it. It's not bare carbon steel. So we recognized that there was a potential for contact, so measures were taken to apply a protective coating to that.
And the seismic restraint, that carbon steel is stainless steel?
That's stainless steel.
Okay. In all your designs, or just at certain licenses?
I'll need to confirm that, but I believe they are all stainless steel. We'll take an action to confirm that.
That's all I of course, to clarify.
Transfer operation, that's done outdoors or that's done within a facility?
It is outside.
Yes. Right, for the NRC. So, 59 so some of the examinations that you've done, you indicate that you found sort of scratches or dents as much as 26 mils or 66 inches. So it roughly corresponds to over 200,000 pounds force.
That is just a local problem.
Yeah, you have to. There's two effects at work here. One is abrasive wear, and one is adhesive wear. So when I don't know which slide it was on, but I made the remark in the presentation that there's roughly 1.2 mils, or we estimate 1.2 mils of depth for 1,000 pounds of contact due to abrasive wear, where you have impingement and erosion of material very locally. When you superimpose on that adhesive wear and some transference of material, what you see are these very distinct, local peaks and valleys where you actually see material being deposited on one surface and removed from the other. So within those local peaks and valleys where you have combination of abrasive and adhesive wear, we saw in the worst case measurement 26 mils.
In a very small area.
So the numerical estimates that we made, those formulas are applicable to abrasive wear, and they can't be used to estimate adhesive wear effects.
I guess my thinking goes back to one thing, the lateral loads, because these 26 mils, I mean, sort of a situation when you've got a sort of a normal or misaligned canister that would rest on the shelf ring, the weight, would be more than 2,500 pounds.
This is not about resting. This is just about sliding.
Yeah, I know. This is because you're considering normal operation as you're lowering the canister and you're looking at the seismic ribs, the axle ribs. You're looking at this, but I guess how do you sort of at these 26 mils? How can you tell that the scratch? It just 1.2 mils. How do you distinguish this number?
The 26, it comes from a measurement that still has an average of close to 0.
Yeah, but I guess you're saying you found cases that you had the 26 mil indentation.
What tells us that we have adhesive wear present is that while we see valleys as deep as 26 mils, we also see where material has been deposited, and we see peaks as high as 20 mils. So there's a very irregular pattern to some of these localized scratch marks where you have pronounced peaks and valleys. So it's clearly not an example of abrasive or erosion wear where you're impinging and scraping material away. You have a transference of material between the surfaces. And we see that more markedly with where there was contact with seismic restraints, where you have austenitic steel on austenitic steel. Yep.
Hi, this is John Wise, NRC. A point of clarification for slide number 9. When you're referring to essentially the margin you have to work with, the design minimum is stated to be 0.216 from an internal pressure standpoint. What would you consider the design minimum considering all the surface loads? to me, when you consider the other loading events, whether that 0.216 is indeed your actual minimum required thickness per your design.
No, you're correct, John. 0.216 is the minimum required thickness per NB 3324. It's an absolute minimum based on the internal pressure only. And then there are other mechanical effects, secondary stresses, as I talked about as well. All of our design basis calculations are based on a half-inch nominal wall thickness, and we carry some safety margin or design margin in those calculations, so that we are maintaining margin over and above the ASME specified limits. Now, in the matter of the scratches and peak stresses, as I was saying, there's no prescribed or explicit limit that comes into play when you're considering the localized surface scratch.
Yeah, I think I understand what you're saying. I just, as you stated, you said you use a half inch in your design. That includes some margin. So what you're telling me is that, well, I guess I'm not sure what you're telling me. How much wall thickness do you need to meet your design stresses that includes accidents and beyond the code internal pressure?
I think a better way of saying it is that all of our design basis stress calculations for the MPC, where we check primary and secondary stresses against the limits, none of those calculations would change. We would not revise them because of any presence of surface scratches on the MPC. Because, as I've said in the presentation, they would be examples of local discontinuities, and they wouldn't enter into the primary and secondary stress calculations where there are explicit stress limits that we are meeting.
I understand your explanation.
This Ron was making, what John is getting at, your design basis thickness for this UMAX. What is your design basis thickness? Minimum requirement. What has been approved?
0.5 inches.
Yeah, 0.5 inch.
No, 0.5 inch, yeah.
So it is a 0.5 as opposed to, I guess, 0.216.
0.5 is the design thickness.
That's what I'm talking about in terms of what is approved for the design.
Yeah.
It's 0.5. Not so much compared
Right.
to the 0.216.
But that's
okay.
yeah.
Right.
Yes, Chris.
If you could, this is Chris Regan, NRC. If you can clarify for us your understanding of the applicability of Section 3 of the code as primarily a design and fabrication code. Understand your understanding of entry upon service, I guess, for lack of a better terminology. Some understanding of when the MPC is loaded, drained, dried, seal closed, backfilled. At what point in time does the MPC enter into service? Clarify that point and how that applies to which section of the code you are using to determine whether or not the scratches have an impact. I've heard both sides. That's why I'm asking for clarification.
Yeah, and I'm not the expert when it comes into inspection matters. I'm more of certainly a stress analyst, but I do know that subsection NB does not directly address design consideration, and we use that to establish stress limits, we do invoke and appeal, to other sections of the code for ND inspections and welding, and so to that end, I mean, there are inspection requirements that do get into in-service and pre-service inspections in Section 11. But I don't know. I'd have to. I guess I would take it as an action to get back to you exactly what would be the defining event that crosses you from. I think what you're asking is sort of pre-service or manufacturing into service space.
That's the question I'm asking. Yes, because that would push you to one code or the other to determine whether the scratches are acceptable or not.
So I think that was I personally wouldn't want to answer that without giving that more thought or consideration and talking with some of our experts back at Holtec. Thank you.
A quick follow-up to actually Marlon's question regarding the painted carbon shield ring. So during this wearing or scratching event, have you noticed or observed that the paint on the shield ring in fact was worn away and you did get transfer of the carbon steel onto the MPC, or do you know either way?
We have seen evidence of wear marks on the shield ring. I can't confirm or say if we've identified the presence of carbon steel on the MPC shell. I don't know the answer to that.
So this is Mike Layton again. The staff comments have run a little bit long, and I want to find out, are there any more staff comments to bring forward? Okay, Jill, what I'd like to do, if possible, could we extend the time so that we give the full 45 minutes for opportunity for comments from folks that are on the phone?
Absolutely.
Okay, thanks.
Mike, if I may, I just wanted to make another comment or remark to John's last question. When you talk about the shield ring and being carbon steel and painted, I just wanted to point out that the high-track transfer cask itself is also largely a carbon steel vessel that has coated and painted surfaces. So the idea of a decision to use painted carbon steel for the shield ring is not new or anything different from the high-track as well.
So are there any more questions from NRC staff? No, I think you're good arranger there. One email comments from NRC CEO. I think we're going to go from this point forward, go to comments from the public and from both those.
This is Rich Turtell speaking. Comments from both the public on the lines. I think we wanted to first start with any comments that are in the room with public participants. Do I see any show of hands of anyone who wanted to make a comment or question on the part of any public participant in the room? Being none? With that, Jill, if we can move forward and open the lines for individuals to present their comments and questions to the NRC in this meeting.
Anyone on the phone line, if you would like to make a comment or ask a question at this time, please press star 1 and be sure to record your name when prompted, so you may be introduced.
After the tone, please state your name.
Nina Babiars.
Thank you.
Our first comment or question comes from Marvin Lewis. Mr. Lewis, your line is open.
Thank you. I hope you can hear me.
Well, first of all, I've heard some interesting things here, especially the ability of engineers to use legalese and talk around the subject such that you wonder what the heck they're talking about. But that's okay. It's America. First Amendment gives them the right to talk like that. Yeah. Okay. It's amazing how many things were left out of what's going on. First of all, the most important thing, I think, is that 9 times in the charter that sets up the NRC and was passed by Congress and all that, that charter states specifically protect the health and safety of the public. And I didn't hear a damn word about protecting the health and safety of the public. As far as the scratches, yes, maybe those scratches won't go very deep, but they will start a lot of pitting, corrosion. They'll start some other types of corrosion. And there's something called hysteresis. I'm not going to explain it. You can look it up in the dictionary. But with hysteresis, you're talking about a static system that is not static. Temperature changes, external temperature changes. There's something called winter and there's something called summer. Hysteresis, it builds up the stresses in the crack, especially after 10, 20, 60 years. Not mentioned. It's again and again. I wonder what language am I listening to? I'm sure not listening to English. Legalese or something like that. Something is missed in the SAR, and that's basis for forgetting about it. No, that's basis for saying the SAR is not adequate. This is the whole thing. I mean, this is a backward, the comments I heard were so backward, something's going on, but I don't know what it is. I sure don't know what it is. There are so many things in here. Primary stresses, secondary stresses, local stresses, peak stresses, but you don't specify how they will be accumulative over decades. Interesting idea. You rule out brittle fracture, which I too would rule out on brand new annealed material. Something like hysteresis will allow the stresses to accumulate, to build up. And then I wonder about brittle fracture 10, 20 years down the line. Or more. This has all been, this has been so much like other things. I remember back when the website was being developed, and I said you can't use organic material as packing material in these barrels and drums. And the NRC promised me in writing, oh, they'll only use inorganic material, bentonite or concrete or something like that. Yeah, they used inorganic material. The waste product of a furniture factory, plywood ground down and used as packing material in the drums. And you know, this is what I'm thinking. I'm thinking, oh, they promised me this, they promised me that. And then we wound up 40, 50 years later with explosions in the drums in the WIP project. I was told that, oh, Mr. Lewis, yes, you won the Lewis contention at 3 Mile Island number 1 restart hearings. And yes, we're going to put a filtered, hardened vent on 3 Mile Island #1 before restart, and they did, because I was at Global and Gantry here in Philadelphia when the truck was loaded, and I had people in Harrisburg that made sure it went on. And that's where it stopped. And to this day, as far as I know, those hardened filtered vents have not gone on any other nuclear power plants after I won that contention at 3 Mile Island #1 restart hearings. So I'm wondering about, hey, they're telling me all sorts of wonderful things. How much of those wonderful things are going to fruition? Too bad. Okay. I've been a materials engineer for over 50 years. I was 1960. I got my license. I don't know how many years that is. Maybe somebody is better at arithmetic than I. I hope so, because I sure did not see anybody good at arithmetic giving me any data that I could hang my hat on. Okay, thank you for the privilege of having my say. I hope it does some good. I doubt it. Thank you.
Thanks, Marvin. I really do appreciate your comments. One thing that, as I was listening closely to what you were commenting on, it sounds like you may have, at some point, some safety concerns. And what I'd offer is, and you're probably aware of this, that if you go to NRC's public website at www.nrc.gov, in the upper right-hand corner there's a button, and I think it's a yellow button, that is for sending us safety concerns. And I would offer that if you feel that there are safety concerns, please do provide those to us. You can do that either through the website, or there's a toll-free safety hotline that will come up once you touch that button on the NRC public website. But I do thank you for your comments.
Thank you, sir. Our next question is from Nina Babiar. Your line is open.
Well, good morning. This is Nina Babiar. Is out in San Diego with Public Watchdogs. And so I have a comment and also a question. My comment is that since the NRC opened this meeting noting that the Holtec request is what prompted it, I'd like to bring into focus a sentence from the Holtec letter that requested this meeting. Quote, "The urgency of this request is propelled by the need to establish a path forward to resume loading at the songs without delay. The loaded transfer cast stranded in the fuel building is one of several compelling reasons that beckon us for an urgent regulatory engagement." That's our understanding of what prompted this meeting. So I'm just astounded that you wouldn't be addressing any of these issues regarding the public safety at San Onofre. And so my question is that the loaded transfer cast, known to us out here in Southern California as can number 30, has been quote-unquote stranded in the fuel handling building for approximately 9 months. What action is being taken by the NRC, Southern California Edison, and or Holtec to procure and install a hot cell to mitigate this unprecedented and continued unresolved risk due to Southern California Edison violations of federal law and the NRC design reviews that are impacting our community? And I really have to ask also, is it just that you're lowering the criteria to meet the incompetence of a failed design to accommodate and cover the Holtec posterior? Thank you.
Thank you, Nina. Yeah, thank you, Nina. This is Mike Layton again.
It's actually Nina.
With regard to your comments on the canister at Southern California Edison, what I would offer is if you would like to reach over to Region 4 office, all of the inspection items that Region 4 has before them right now. The canister that's on the loading floor and also the restart question on whether loading would continue. And like I mentioned at the start of this, even though that was mentioned in the letter from Holtec, because these are inspection issues that are before the agency now, we're not in a position to comment on those in this meeting, but I would encourage you to reach over to Region 4.
Yeah, Nina, this is Linda Howe, and you can certainly reach back to me. I think you have my email and my phone number, and I'll be happy to answer your questions related to Southern California Edison. But the purpose of today's meeting is for Holtec to provide a presentation on changes that they are pursuing for their certificate of compliance and the final safety analysis report.
Well, you know, Linda, I did approach Region 4. I approached Scott Morris after the...
Thank you. Our next question is from Torgan Johnson. Your line is open.
Yes, this is Torgan Johnson from the Samuel Lawrence Foundation in Southern California. And first comment is the loading system that transfers the canisters into the ground is a defectively engineered system, so much so that the canister was not aligned with the opening through the guide ring and hung up. So it's clear that the axis that this canister needs to travel was not lined up with the rig and the canister. So the canister can move off axis, damaging the canister on the way down. The photos that were circulated of the opening of these spaces that the canisters are dropped into show the guide rings with damage and show the vertical guides, the seismic guides, damaged on the top corner where the canister would come in contact with them. Samuel Lawrence Foundation did a white paper that analyzed the potential scratches given that system, and the scratches are potentially significant, so much so that they become a safety issue. And that's with just one pass through the guide ring. What's not being discussed is that you have a cumulative effect of the fact that that canister is going to be pulled back out through that defective system and scratched again. Then that canister is going to go to a CIS facility and once again damaged as it's dropped into that facility. So you have 3 times the damage. If the canister is not aligned properly, then that damage could happen right on top of the previous scratch as you pull this canister back out. I find it uncanny that the discussion here about the damage and allowing the entity that created the defectively engineered system is almost a repeat of the same process that allowed Edison and Mitsubishi Heavy Industries to try to justify their defective engineering. Where is the entity that defends the public interest in this? And the fact that the public has paid for everything, either as taxpayers or ratepayers, and is relying on it, which Holtec accountable for what it promised to do. If Holtec's system is damaging the canisters, that's a defective system. In any engineered system, when you have metal-to-metal abrasion that wasn't intended, you have a defective system, and that system needs to be recalled. Clearly, we have a defective system here, and the discussion today didn't even talk about the consequences of the scratching and the gouging that we calculated, which absolutely becomes a safety issue as corrosion cracking starts to compromise the integrity of containment. I would like to see the analysis by Holtec
apologize.
No. I was simply going to comment on one of Mr. Johnson's comments that the system, Holtec system, needs to be recalled, and point out that there is an opportunity for really any person to ask the NRC to take an action, whether it's a licensee or a vendor. And provisions that we have for that are in 10 CFR section 2.206. So if you wish to bring that type of request or action to the NRC, that would be the process to bring it forward. Thank you.
Thank you, sir. Our next question is from Kate Magda. Your line is open, ma'am.
Thank you. Thank you for today's meeting. I do also feel that today it would have helped to have heard a more careful look at the dangers of the canisters being loaded down into the system, and so that the public is feeling safe, that everyone using the system has a better way of doing it than has done before. So that's one of the things. I'm wondering if, as I hear about the scratches are a normal thing, do we have data on any dry storage vertical system with its scratches? And then I guess my last one, and of course I'm certainly not understanding exactly what I'm hearing here, but when you were talking about local stress on the canisters and peak stress, it's a passive system, so that would be minimum problem. But when we think of the world right now in global warming, temperature change, I'm concerned that, say, if we had this system in the desert and for a decade or more, 2 decades, if the temperature outside temperature goes to 110, does the canister survive that down in the earth? Those are just questions that come to my mind that I couldn't understand. I heard sometimes words implied and sometimes the use of the word alara, and so I just would like it as clear as possible so that we all feel safe about the system that's being used. And thank you for listening to all of us.
Yeah, thank you for your comment. The one perhaps question that I have is, I am aware of the community engagement panel activities that are associated with Southern California songs. And it sounds to me like those are good questions to bring up in that venue if you have concerns with those questions.
Thank you, sir. Our next question is from Kayleen Walker. Your line is open.
Hello. I too am curious about the status of canister number 30. I also hope that there's a transcript to this meeting because quite a bit of the conversation was not easily understood. I find it odd that Holtec continually references ASME codes, yet they are not ASME N3 pressure vessel certified. So I'm not sure how they can, make references to those codes when ASME is not even involved. As far as questions that we ask, I just wonder when we might get some answers. We've sat through quite a few webinars and all, and there's over 33 pages of public questions just from the chat rooms, and you posted the questions but not the answers. So it would be really great if we could get some answers on that, and particularly considering the risks of chloride stress-induced corrosion and cracking. I'd really like to hear the NRC respond to Donna Gilmore's question related to the risks of potential explosion due to the high burnup level of fuel. So ML 18269A037 would be a really good one for the NRC to respond to. And I think that's all I have to say for the moment. Thank you.
Okay, thank you, Ms. Walker. Just for clarity, there is no transcript for this meeting. Many of the interactions that we have in Category 1 meetings don't do transcripts. We do have a summary note that will be posted on this, and it will be in Adams. And I do thank you for pointing out that we do owe Donna Gilmore a response to the stress corrosion cracking question that was put to me personally whenever I was talking at the Diablo Canyon Union Engagement Panel meeting. I do owe Donna a response to that, and it will be forthcoming.
And Kaylee, this was Linda Howell. I'd also add, we did receive your most recent correspondence and questions to us, and both my team and my team will be putting a response together for you. I think that again, this is a Holtec meeting, so I don't want to get into specific details concerning the status of field transfer operations at the San Onofre plant. We have addressed canister number 30. Its status has not changed. You are free to contact me if you'd like to know more about that. But I think you raised another question early in your comment that we perhaps should turn over to Dr. Anton or Mr. Hamid, and that has to do with the ASME qualifications for canisters. So if you want to repeat that, perhaps they can address that for you.
I think she's offline to her. If I could remember the question, Ms. Walker said the question she had was that Holtec is using ASME codes for pressure vessels for their designs, but yet Holtec isn't ASME code certified. I guess is the question. I think that's what I heard.
I can address that. And so I will just point to this is Marlon Davis, Division of Spent Fuel Management with the NRC, and essentially in the certificate of compliance with Holtec Appendix Bravo, which is their design features, Section 3.3 is the codes and standards the UMAX, MPC, and the FW is used to, and it identifies all the code compliances and the alternatives that they're taking. And that's one of the alternatives that they're taking, that they're not stamped. And we review and approve that particular CFC, and we identify in our safety evaluation report on what they had committed to and what they did not commit to.
Thank you. Our next question is from Rich Van Every. Your line is open.
Yeah, hello. Thank you. I am a filmmaker in San Diego, and I'm just looking deeply into this issue and finding it more and more concerning the more I hear. And probably the most frustrating thing for me is the fact that the NRC's primary job is to protect public safety. And here we have a situation where hundreds of millions of dollars are being invested into a system that doesn't prepare the waste for transport off our coastline. It's criminal enough that a storage site was approved 108 feet from the Pacific Ocean in what I consider a defective storage system that is consistently downplayed of the long-term risks that we're all facing here. Just as Miss Walker had mentioned, these, statements by Holtec seem very frustrating to me when these pressurized vessels don't even have a release valve and they can't be internally monitored. They're not suitable for transport. And here we are putting ourselves into a predicament, even a worse situation than having just left the fuel in the pools for now until we get the proper canisters to be able to transport this waste and monitor it safely for decades to come. So what's happening right now is that we are using a defective system that's a temporary solution with no foresight and no hot cell on site. So my recommendation to the NRC, and please, it's a waste of energy to ask me to address my concerns with the community engagement panel, which, does very little to take action on this issue. They're seemingly just entertaining our concerns and projecting their own propaganda. Not to mention that, going to District 4, yes, please, I will submit my answers to my questions to them. And, this is a bigger issue that's going to require some change in policy so that the NRC does their job of ensuring that public safety is a priority and not the convenience and profitability of corporations. And that's what it feels like is happening, and it's not okay. There's way too much at risk, and I want a lot more explanation about how, Scott just recently released this video and downplays the risk of what a leak would do, or the risk of a hydrogen gas explosion if there was a crack in one of these canisters and oxygen got inside of it or water got inside of it. What's going to happen and how are you going to handle it? There's no backup plan here. There's no defense in depth. It just doesn't make any sense to me. So I really hope that you guys find a way to require thick-walled casks that can be monitored, inspected, and transported, and also a hot cell so that we have a backup plan. If anything does go wrong, we have a way of mitigating the situation before it's literally too late. So thank you for taking my comment.
Thank you, Mr. Van Everett. Again, I'll refer you that if you have the opportunity that you can ask NRC to take action along any lines that you talked about, and the provisions for that are in our regulations in 10 CFR section 2.206. So if you do wish to avail yourself of that, that would be proper process for that. I would like to comment on one of your statements when you said that the casks cannot be transported. The design for this certificate, the High Storm UMAX, is approved for both storage and transport. So at some point, as a location becomes available, whether it's another centralized ink and storage facility or whether it's final disposition in some repository, those canisters can be transported. Thank you.
Thank you, sir. Our next question is from Donna Gilmore. Your line is open, ma'am.
Michael, this is Donna Gilmore. I had asked you at the Diablo meeting, did your staff know that there would be metal-to-metal contact, that the system Holtec is using is not a precision downloading system? Did you find the answer to that question?
I think it was presented here, yes.
So you knew about this before the UMAC system was approved?
Are you talking about me personally or the agency?
I'm talking about whoever approved, not you personally, but whoever approved the COC, did they know that there was going to be metal-to-metal contact because it's not a precision loading system?
So I'm not quite sure
This is Niraj Rahimi, NRC. Yeah, at the time that the used again, this was based on the information that was presented in the safety analysis report, in the tech spec, and for this particular design in the SAR, there was, as Stefan presented, there was a statement that they did not anticipate any sort of scratches. However, in the other systems that we have approved, we have considered scratches, and there hasn't been any safety concern. But I think in this case, if the Holtec is planning, or they have done 7248 to revise that part of the FSAR, and of course, as during our inspection, we will look at that 7248 and we will look at the technical basis for that.
Okay, so what I heard is that at the time the UMAX was approved for Holtec because of the information provided by Holtec about there would be no metal-to-metal contact, that you assume they would have a way to prevent that with their loading system. So, since we now know that is not the case, this is obviously a safety issue. There should be a license amendment. I think the NRC has excellent staff, but it's time for their management to be brave enough to take on Holtec and whoever the politics are that is giving him such influence, and let your staff do their job, Michael, and do a license amendment, and let's just get everything on the table. I've worked in government before. I know how it is to feel when you have a boss that's not going to back you up to do the right thing. And you know doggone well this is going to be pit corrosion cracking. It's going to be crevice corrosion cracking. You're going to have crack growth rate. These canisters are 200, 300 degrees Celsius, according to Tom Palmisano. Tom, you don't have to speak, but you have multiple times told me these are 200 to 300 degrees Celsius. That means the crack growth rate is going to even be faster than the 16 years that the NRC told me it would be back in 2014 when you're talking cooler canisters. So let's get real here. Forget trying to send it to somebody else. Don't send it to Region 4. It's not the inspection issue. Don't send it to some petition. This is your responsibility as a design division chief or manager, whatever, to be responsible that you ended up approving something where you were given misinformation, so they need to do a license amendment to fix this. These Holtec systems are crap. These are lemons. The above-ground systems, I researched those since finding this out. They lack precision. You got carbon channels scraping the entire sides of the canisters in the above-ground Holtec systems, and now you're going to be okay with putting this in New Mexico, too? Let's get real here. Thank you.
Well, thank you, Donna, for your comments, as always. I would like to encourage you that some of your statements indicate that you feel that NRC's management is providing undue influence over NRC staff technical reviews. And what I would ask you to do is, again, go to the webpage, www.nrc.gov, and if you feel strongly about that being a safety issue, please send it in to reporting a safety issue with NRC. And be specific, please. Thank you.
Our next question is from Susan Snipes. Your line is open.
Thank you. Thanks for creating this meeting today that the public could be involved with. I have to echo and reiterate what Donna Gilmore is saying, and also what Kayleen Walker is saying. And what is very interesting after being late in the public comment right now is that it's very obvious that there is a common thread running amongst everyone that's calling in. And we're being told, well, go to this website, or even more frustratingly and scarily, looking at Holtec as the expert because they've created these, and yet they're not addressing safety issues. They're addressing the operational nature, how it's loaded, but nothing to do with the safety issues of the canister that they're creating. I have the same question stated slightly differently that everybody else had. How do you account for the environmental stress, like a salty, moist, sandy environment that accelerates corrosion even with minor scratches over a period of time? And that is, I have not heard those words or anything even alluded to at a CEP meeting. By the way, I live in San Clemente, California. At a CEP meeting, it's basically a cosmetic tool by SCE just so that there's somewhere where our concerns can be listened to, but nothing is done about it. And I have to tell you, when you are us, Michael, sitting here, and hearing you say, well, go over to the website at NEC and go over to the left corner and click here, and then be sure that you're very specific and be sure that you write it all down, which Donna Gilmore's already done and hasn't gotten an answer. Please do not be condescending to us anymore. I have gone to several meetings now, and I've become very concerned about this because it is just a hot potato that's passed. How about somebody, as Donna mentioned, be brave, do the right thing, and address the safety issues of these canisters to explain away these scratches when there's already proof out there and data that shows, yes, even minor scratches can have the corrosion accelerated in a marine environment. That is apparent. And also, as I read on the website and went deeper and deeper, the Holtec meetings that are being held across the United States, excuse my naivete, but oh my, it's not just a situation here. This problem is prevalent. You've got a lemon here. Deal with it. Change it. There's $5 billion to take care of this issue. Perhaps a lot of it's spent now. Do the right thing. I rest my case.
This is Mike Layton, and I apologize if I appear to be condescending when I try to direct your concerns or comments either to our allegation program or petitions to the NRC. I offer those because those are truly the paths for public to put their concerns forward for the agency action, whether it's going to that little button in the right side of, or upper right corner of the web page. That puts you in direct contact with our allegations program. And the NRC's allegations program takes these things very seriously. And if you do go there and read through what comes up as you talk about that, or as the screen comes up and tells you what the allegations program is, I'm encouraging you, if you do have the concerns, please bring them forward in that venue because they will get addressed. Similarly, with putting petitions forward under 10 CFR 2.206, those requests do get addressed. So I apologize if I sounded condescending, but I'm trying to be helpful in guiding you to the processes that we have that will result in action. Thank you.
As a reminder, if you would like to make a comment or ask a question, please press star 1 and record your name to be introduced. Our next question or comments from Rob Nikolewski. Your line is open.
Hi, this is Rob Nikolewski from the San Diego Union Tribune, and I'm hearing myself on the. Hang on a second. Yeah, one of my questions would be in regards to Mr. Layton. Could you tell us a little bit more at the very end of the presentation before you took the public comment? You were talking about the fact that Holtec can make the changes to the FS or to the FR, and that they might be under review by inspection from the NRC. Could you give a little bit more detail? Then I have a follow-up after that.
Oh, certainly. What you're referring to is what's outlined in our regulations under 10 CFR 72.48. And this is a provision, and it's not unique to the Part 72, which covers Holtec. It's also in many other regulatory requirements in a similar fashion, even with the power reactors. And it allows a licensee, or in this case, a design authority, which is Holtec, to make certain changes to not the technical specifications to the design, but to the final safety analysis report that was submitted as part of the licensing basis for the certificate. And if you go and look at the provisions in 72.48, they're very prescriptive in a screening process, so to speak, as to identifying when it's appropriate for the design authority to make those changes and when it would not be. Or I should say, if the screening doesn't, so if the design authority can't go through all of the 8 criteria for the screening, then the decision is that change needs to come into NRC as a license amendment. So I hope that clarifies it a bit.
Our last question or comment at this moment is from Dan Budar. Your line is open.
My question is about what has been left out of the talking that I've heard for about the last 2 hours. There was a gentleman, the first gentleman who presented the bulk of the slides, who talked about metal fatigue and whether or not stainless steel is ductile. I didn't pick up, I thought stainless steel was not ductile, but I didn't pick up what he said. Now, metal fatigue is a problem, of course, but the fogging or the ignoring the fact that these canisters will be subjected to radiation bombardment, which has to be added to the metal fatigue and will cause embrittlement of metal. Embrittlement is ignored at Palisades, and in Japan there are reactors that were not started up again because they already knew they were too brittle to start up, and yet we talk about these physical processes that don't involve atomic radiation, and I'm really amazed that you can, pardon the expression, get away with talking about the fatigue of materials without adding in the fact that these materials are going to be bombarded by radiation over a period of many decades. That's my comment.
Hi, this is John Wise, materials engineer at the NRC. Just to clarify, the effect of fatigue and the radiation effects on materials is a big part of our materials review of all of our storage systems that we approve, and this includes the high-form UMAX. So as a matter of course, when our materials engineers, we have several, look at the certificates like the UMAX certificate, we look at the specific materials they propose to use, and we evaluate those against the environments to which they're exposed. This includes the effect of radiation and potential embrittlement of certain materials, and it also includes how these materials behave as they go through the cyclic temperature fluctuations that have been discussed here a few times today. We've heard a few people bring up the night-day or the heat of the day temperature fluctuations. Those are all part of our review as materials reviewer, and actually the ASME code also forces the designer to go through a process to evaluate the fatigue behavior of the materials.
Thank you. Our next question and comment is from Ace Hoffman. Your line is open.
Thank you. Can you hear me okay?
Yeah, you're coming through fine.
Okay, great. I wanted to comment on some of the previous comments. So that last comment was kind of a helpful response in itself. Because regarding Marvin Lewis's, the first comment that we heard, it would have been nice to have been given how many miles we think that these things can travel without additional damage once they've been sitting at the reactor site for how many years. So how many years are they expected to not become too embrittled over? How many years are they expected to sit and wait? And I was going to ask, what is the temperature difference between the bottom and the top of a cask at the peak of the day and the end of the day? But obviously you've taken some of that into account, but it'd be kind of nice if you had those kinds of numbers available to us. And regarding the scratching on the way in of canister 30, is it possible that the reason it was scratched was not because they had not positioned it properly over the canister, over the hole as best they could tell, but it wasn't standing perfectly vertically because it wasn't loaded perfectly balanced? Would there have been some way that the internal material inside the canister had become unbalanced? That's what I'm trying to ask about that. Okay, that's all I've got. Thank you very much for taking my question. Oh, one more thing. Are you assuming that the construction of these canisters is proper? Because there's approximately enough waste right now for 10,000 canisters, and we have about, 3,000. Are you assuming that every one of them is properly constructed? Because that's what I've heard the NRC tends to do. Or are you giving us the results of what you think is the worst case construction effort of all those 10,000 canisters? Thank you very much.
Yeah, thank you, Mr. Hoffman. Yeah.
The next question is Gary.
We have a response from Mr. Hoffman.
Sorry.
This is Baraj Rahimi, NRC. I guess going back to your question, comments, basically. The transfer, I guess I start from the last comment or question that you had. Do all these canisters are, fabricated, the same? And, we have a sort of an inspection program. As part of the inspection program, actually, we go and we look at the fabrication process, and all these fabrications are done according to the designs that we've approved with the tolerances, with the material. So, the inspection program actually, provides that assurance that these canisters are fabricated according, to the design specification that we have approved. Then the second comment was, which was would it be unbalanced as it was stored? I think generally, these canisters, it doesn't have to be, unbalanced. Of course, when you, load these canisters with 32, 36 assemblies, with all the shims in there, they are not, the weight is not perfectly distributed, but the hoisting of it generally is balanced. But it's the nature of operation as you lower it, because as it was explained, there is a tight tolerance because of the seismic restraint, the axial seismic restraint, and the shield ring that it would, touch, those materials. The nature of the operation. And then your first some miles that they travel after long storage. And actually, when after they are in storage, if they're going to be transported, they have to meet the transport certificate of compliance, whatever overpack they are using. That means the canister condition has to comply with the requirement, provided what kind of a safety function that canister is performing for transport. So in most of the cases, the main safety function that is relied upon is the overpack that's providing the containment. And in some cases, if the canister is relied on in terms of providing a water barrier as a secondary barrier, they have to meet the certificate of compliance conditions. So the COC, transport, actually there are those conditions in there, and the shipper in this case has to make sure that the canister they're shipping, it meets all the transport COC conditions.
So I think we have time for one more comment or question.
It comes from Gary Hedrick. Your line is open.
Hi, this is Gary Hedrick with San Clemente Green near San Onofre. I just wanted to add a few comments, just some things that were already said, and also relay a story that I think is relevant. The photos that we saw of the downloaded canister, it's obvious that the paint has been scraped off, and so the assumption should be made that dissimilar metal-to-metal contact is inevitable. It sounded like you're considering further inspection, but I think we can assume that. Another comment or two that I agree with wholeheartedly is that we have to have a contingency plan. We already know that their temporary storage of canister number 30 is in question. It's probably been there too long, and it's because we don't have a proper solution to this situation. So that, I think, is a big responsibility of the NRC. And my next comment about the NRC and your, what areas of jurisdiction you have kind of reminds me of a story I heard back, not a story, it's what I witnessed at a CEP meeting where the CEO of Holtec, Kris Singh, was being asked very respectfully by a member of the community about an incident involving the TVA, Tennessee Valley Authority, and charges of bribery from Holtec, and that there was some fine of $2 million, and then they paid that, and then soon after that, they were barred from continuing to do business for 3 months, and then they landed a $30 million contract after that. But when she brought that up in the meeting, Kris Singh just tore into her. He was so, irate that someone would challenge the reputation like that in public and be so irresponsible and, just being, reckless with this, these accusations. And then she came back with the actual documents from the TVA, and it was an administrative fee, not a fine, but there had been no such administrative fees in the past, and it was for bribery. And now their Canadian partner, SNC Lavalin, they're currently under indictment also for bribery. So it appears like we're working with crooks and criminals, if you just want to be blunt. And I just wonder what the role of the NRC is in this situation. Do you look into the integrity of these people you're working with? Is that even relevant, or is that someone else's concern? That's it. Thanks.
Yeah, thank you, Mr. Hedricks. We do look into allegations of those types of things that you did mention. And as you talk about the partner with Holtec, that really is focusing on a licensing action or a licensing transfer that's before the NRC right now. So those are things that do get examined and do come into consideration when we look at a license transfer for material. they have run a little bit longer than normal. I did want to give the callers ample time to give us comments and give us an opportunity to respond as best we can. I do thank everyone that called in for their patience and also the good quality comments and good forum that you expressed with giving those comments. I want to thank Holtec for taking the time to present their information to us here at NRC. And with that,
again, this is Rich Turtell, and I do request, if you do want to be part of the attendee list, please send me an email with a short little title that says "Include me in the attendee list." And I've reached out to really many of you with the information for this meeting. So just shoot an email back to me. I greatly appreciate that. You'll be on the record.
Can you state your email?
Yes, my email is Richard, RICHARD, .Turtill, T as in Tom, UR, T as in Tom, IL, at NRC.gov.
So thank you, Jill, for moderating for us. And with that, this public meeting is completed. Thank you.
That does conclude today's conference call. We thank you all for participating. You may now disconnect and have a great rest of your day.